forget where that is. But all right, we're recording now. Let me get the chat up. All right, so let's get started. We have a lot of, just want to make sure I'm recording. Yes, I am, cool. We have a lot of content to go through. I want to go through homework 2, just to make sure no one has any questions about that. All of your grades should be back, so if you don't have a grade, let me know and I'll get that back to you as soon as possible. Overall, people did great on this, and I think people were, really getting, how something like BigViz could really help with working with larger data sets like this. The main point of this assignment was, what sorts of strategies do we have for dealing with these larger data sets? And I thought a lot of people had some creative answers. So with that, we'll go through just a couple of ways of working with this data, and then we'll look at sort of begin going over what you'll need to know for homework 3. So looking at Shiny and getting some basics of web development. Did everyone on the call get my announcement last weekend about I posted a video? Cool. Cool, yeah. That was meant to be a short video. It ended up being 45 minutes, but it's there's just a lot of content there. And what it's meant to do is just sort of give that introduction to Shiny and going through, a couple of graphing libraries that make more that sort of take on new importance when you're building Shiny apps. So I'll check that video out, and I'll just sort of answer any questions anyone had there. But I have the code up from there too. So with that, let's get started here. So the first step in looking at this data was being able to combine combine all of these into one CSV. This is, obviously with this data, it's divided by borough, but with a lot of larger data sets, you're dealing with data that might be broken apart, and there are different ways of dealing with that. And overall, the thing to keep in mind is this, you need to really think about how you're dealing with your data. Like the way that I always think of it is if you have a smaller data set, it's easy to kind of just strong arm your data wherever you need it. And it's difficult with larger data sets where, if you try to perform an operation, it could take a while. So you need to, really keep that in mind. Like if you're like performing exploratory data analysis and you're kind of doing things iteratively, try to minimize the amounts of large processing that you're doing. And lots of people, they use different ways of combining them, either using CSV Kit, which is a command line tool. A couple of people use that. A lot of people just did it in memory, which is fine. Like you could just simply read all of the CSVs into R and use R operations to combine them into one data frame and either write that to CSV or just simply use that in memory when you're beginning your visualizations. But everyone seemed to be able to get the data together. And so we'll look at just a couple of things here. So I'll bring in the data and look at just doing some initial filtering and getting some columns ready for what I'll be doing later on. And while we're reading that in, we'll just look at the questions that we had here. So similarly to the last assignment, like a lot of these questions, there's some interpretation, and this is really like these questions are a bit open-ended, which is sort of just getting you guys to think about like how you're able to answer these questions. So with the first question, we're just looking at older buildings. So like all this, you're pretending to be an investigator for the city of New York. We're looking at older buildings, and we're trying like sort of looking at what is a cutoff date before most city buildings were constructed. So it's really not about the particular not the like this is something that's more open to interpretation. So if you're looking at like something like this could be interpreted as when like you could simply use like a median. When is the when were 50% of buildings constructed? So there's a couple of strategies to looking at something like that. Now, one thing, and I mentioned this in the when we were talking about BigViz before, is BigViz. It's very good with autoplot. So normally, I mentioned that it's not the best to use autoplot. Like it's better to kind of take an active role in how you're building these visualizations. But with a lot of times with BigViz, like the way that you're condensing informs the type of visualization that you're using. So this is kind of one exception there. So the first thing that we can look at here is just sort of looking at counts over time, like looking at each year, and we kind of get our first inkling that something is going on here. You see these weird spikes up here, and kind of becomes smooth over here. And the vast majority of you guys got that. It's like all these are grouped by 5 years, and it's just simply it's not the best data, which unfortunately does happen with in a lot of cases. So in this case, like before the 70s, a lot of this data is kind of grouped with the nearest 5 or 10 year periods, and looking at this alone, it really does throw things off because it makes it seem like more buildings were built in individual years where there are records. Looking at it here, and that's not something that we want. So the question is like, how do you deal with something like this? And a lot of people seem to understand that there are ways of dealing with this. Some people, and it was really cool. Some people like did some more digging and looked at the sort of external sources about this data and what could be causing things like this. And there is a lot written about about this sort of data, but it was obviously not required for this. But it was really cool that some of you guys ended up going through looking up the background of this data. But since we are dealing with such a large data set and we're working with BigViz, one of the easiest things to do is to just use a different binning for the years. So instead of binning by every 1 year, you could bin by every 5 years, and that'll give you more accurate data about what your counts are. So here, by simply changing how we're binning it, looking at 5 years, you could see that we get more of an idea of of like when buildings were built. So you could see like there was a huge amount of New York that was built during the 30s, 40s here, and kind of tapers off a bit. And then in terms of what the actual, so just in broad strokes, like that's where this is giving you an idea of um, you know of when buildings were built. And to more accurately answer the question as posed, you're able to look at accumulative data to look at this cumulatively. So if we look at this here, and I'll have to run all of these. If we're looking at this cumulatively, you could get more of an idea of when most of the buildings were built. So here, steeper slopes. That's when more buildings are being built during those years. So as expected, like during the 40s, 30s, we have steep slopes, and then it kind of tapers off here, and we're crossing that 50% threshold right here. Most people came up with visualizations that were, along these lines. So, any questions about question one? Cool. So, we'll move on to Valerie. Can you be a bit more like in terms of smoothing it? Do you mean just getting rid of these steps?
Yeah, I started without big whiz, and then I, I didn't know how to like smooth it out and grouping it. I don't know. I just couldn't do it, so I left it as individual for this one.
Mm-hmm, mm-hmm.
But like you use the smooth function. I was trying to use the smooth function in big. Is that big whiz?
I believe so.
Yeah. Like
The
I don't know. Is it
Yeah.
like do you have to bin it first and then use the smooth, or can you use the smooth function to try to? Because in individual, you're like it's like a step, right? You have like 5 dots and then you jump and five. It's really
Mm-hmm.
so. I was trying to smooth it, but I just couldn't get it done. So I was wondering how you do that.
Well, for a cumulative graph, you don't really have to worry about that because it actually, um, you know, it, like you have to worry about it more when you're looking at that first graph. So going back to this first graph here, where we're just looking at the counts, that's so before we binned it, like this is seriously misleading because it's leading us to believe that there were more buildings like substantially more buildings, like 10 times as much, as many buildings built during these years as during later years, and that's not true. It's more, it's more on this order. So that's where you really have to worry about it, and the smoothing. The smoothing really happens when you're binning it. So I guess that's where you would worry about that. But for cumulative sum, I wouldn't worry about smoothing it. Any other questions? Cool. Cool. So looking at the next question, so we'll go back over here. So the next question, this is kind of similar to the first question, but we're looking at we're sort of looking at groups of buildings. So rather than looking at like all buildings overall, we're looking at if there is if you're looking at sort of the first couple of skyscrapers, the first few 30-story buildings when the technology to build those buildings first came out, being like being able to get an idea of how many of those sorts of buildings we need to worry about. That's really what this question is getting at. And this one was a bit more, nuanced in terms of how you would be able to answer something like that. So the first thing that you could do is just, simply take a look at all the data together and see if you could notice if there's any patterns that become apparent. So here, what we're looking at just number of floors over time. So you could see we're binning the year built and number of floors. And in this case, when you're when you're binning in 2 dimensions, by default, the auto plot gives you a heat map of, essentially a binned scatter plot of what we're looking at. And so many people started out by looking at it this way, so you could see kind of when that buildings do get taller and taller over time. You could kind of see like around here. This is when elevators started. When elevators became more readily available, so you're able to build taller buildings. Like that's really the kind of major hurdle that allows you to build buildings taller than like around 8 stories or so. But this doesn't really give you an idea. It doesn't give you too much of an idea of like out of buildings of 20 to 29 stories, how many when were those first buildings built? When were the first 30-story, 40-story buildings built? In order to look at that, you need to have another approach to looking at the data. And a lot of people arrived at this. A couple people had some creative solutions to looking at this. One of the most straightforward is just simply dividing the data into kind of 10-story chunks. So here what we're doing is we're looking at, we're just dividing this into these 10-story chunks and using small multiples to get, to kind of get cumulative plots of each of these chunks. So here we're getting an idea of like, down here, this is going to be where the first few buildings are. And we're finding out like how, what these distributions look like. So you end up with some interesting patterns. So you have, you sort of have some like, construction slows down, it speeds up again. And you definitely have some areas where if you were seriously looking at this, like when you would be concerned about buildings of certain heights. So, 10-story buildings, we could sort of use the cutoff that we used before of just 50%. You pretty early cross that 50% threshold when you're looking at buildings of 10 to 20 stories. You get that looks like around 1925. But then as you're getting to taller buildings, you cross that later. So here you're getting into like the 1970s as you're getting into these 30, 40, and 50 story buildings. So while a 10-story building, you would probably feel safe, feel safe with a building that was built around the 70s because we've been building these buildings for a while, so it's a lot of these best practices have been established already. Whereas with these taller buildings, you could make the argument that like even if a building maybe were built in the 60s, even if you have a 30-story building that's built in like the late 50s or 60s, that might be suspect because best practices may not have been developed yet. And with this question, there were a lot of people who had a lot of creative answers to this. Like a couple of people, when they faceted it, they sort of like rather than in this case, like this is just using facet wrap, but a lot of people sort of used facet grid and really drove home the point that like um, kind of looking at the pattern of how buildings are getting taller and taller. So you could kind of see like you could see like these buildings are built mostly earlier, then these are later than 10-story buildings, these are later than 20-story buildings, etc. So there was a lot of interesting visualizations that sort of brought home that point. But really looking at that question, that's taking a strategy like this is the best way to look at that. Yep. So I had a few. I had a few. One in particular. Um, where so this is Dan Finelli's homework, which he ended up really going into the background of the data, which I found really interesting. Um, I forget how he. So and he also had a lot of interesting choices for for looking at like different groupings of numbers of floors. So in this case, he ended up sort of rather than using small multiples, putting it all in one chart, um, which you're able to. This is just another way of looking at that pattern. And I believe put it. Um, well, I had one out, and I'm forgetting where exactly I put it at the moment. Just bear with me for 1 second. But it was Kishore who also had the sort of stacking it rather than showing it in a facet wrap, which was really good. Yep. So here, this was that pattern that I was talking about, where you see different building heights, and you're looking at years over here, and this gives a pretty clear pattern uh, of when buildings are built. So you could sort of see the sequential nature of um, of how this development is occurring. But yeah, a lot of people had um, really interesting ways of looking at this. Any other questions for question two? Cool. So um, question three I found fairly interesting because um, uh, there were like I wouldn't say there was like a wide variety of approaches that people took, but there were a few sort of um, alternatives that I didn't really um, that a lot of people sort of arrived at. So um, we'll just look at some ways that you could look at this. So the this third question is um, we're thinking about World War II, and we're trying to find out like are buildings built during this period more poorly constructed than others. And one way that we could look at this is by looking at assessed value per floor. So everyone got the fundamentals of this, where you need to calculate the assessed value for per floor, which you have assessed value, you have number of floors, so it's pretty easy to arrive at that. And so simply we were looking at kind of over time, how that is changing. or actually, so the approach I took was looking at that more over time. Um, but a lot of people took this a bit more literally and kind of divided it into more discrete chunks. And there's positives and negatives to each of those. Like there was, I mean, I didn't consider one more correct than the other, so there is nothing I would say wrong about that. It's just a question of when you're asked a question like this, do you use, in this case, the date range that's defined as when the U.S. was involved in World War II, or do you sort of have a visualization over time, um, kind of make that comparison and make the visualization almost inform, what your division is, so that um, so that you sort of look at a wider range rather than looking at, this is before the war, this is after the war, this is during the war, etc. So, and I'll try to, I don't have any prepared right now, but I'll try to get an example or two of people who sort of looked at it more discreetly. Um, so basically, looking at it like this is looking at just assessed value over time, kind of overall. Um, Let me move this GoToMeeting here. So this is looking at the sort of a heat map of assessed value. So we have assessed value per floor, and then we have years over, looking at years over here. And if we wanted to make this pattern a bit more clear, we could choose an alternative way of looking at this. So here, what we're doing is we're looking at sort of what we've been doing in the past, like binning it in 2 dimensions. So in this case, we're binning year built and value per floor. But this really, like this is meant to be more of an exploratory technique rather than really giving concrete answers of this question. So what we could look at is using Big Viz with 2 variables. So rather than binning 2 variables, bin 1 variable by another variable. So in this case, we're binning year built, or we're binning value per floor by year built. So we're looking at that in 5-year chunks, and we're going to look at the average value per floor. And when we do that, we're getting our mean. And all of this is just getting rid of a couple of outliers, which sort of make this a bit harder to view. Once we do that, we could just look at that. And so what this is giving us, this is giving us a lot of information, considering a lot of information on this. So we have like by, with this color scale, we're looking at the count. So we're getting a bit of an idea of how many buildings were built in these time periods. So, fewer buildings were built here, more were built in, the 40s, 50s, like pretty much the patterns that we've seen before. And this is giving us some cool patterns. Like for instance, you could see that older buildings, they seem to be valued higher per floor than other buildings. Which, if you think about that, that kind of makes sense because these buildings have been around for a while. A lot of them are historic, so there's sort of historic value to them. There's an interesting sort of drop here at 1900, which you could kind of think of as, these buildings are buildings where you knew the pre 1900 build date. And here, this is just for, all of the old buildings that aren't really being taken care of, that you don't even really know when it was built. So you kind of have a lower value there. And then you could see how things are changing over time. So you could see a lot of newer buildings. You definitely have an uptick of newer buildings Should have gotten rid of that. I believe that's an outlier. Um, but you have this uptick as you're getting to the later 2000s. So that perhaps is showing that there's you have like newer buildings, fancier buildings, like higher buildings with more amenities. And what we're really looking at though is what's happening during the war years. And um, you could kind of see there's like a bit of a dip, but to be honest, you wouldn't really be able to answer this question without more sophisticated techniques. So for something, a couple of you guys sort of guessed like what you would need to do. Does anyone know what you would need to answer something like this? What kind of statistical technique? Yep, it's essentially hypothesis testing. Like you would just look at, and actually, the way that one person looked at it, they used box plots to show, to show the distribution, and it's essentially you would need to, generate a, sort of test a hypothesis. So you would need to test like, is this distribution significantly different than buildings built outside of that period. Um, but people had a lot of interesting ways of looking at it. So like what I mentioned, where this is looking at it over time and kind of letting the um, rather than sort of defining a specific period, like the war years are from 1941 to 1945. We're just looking at it over time and just seeing like what is the overall pattern? Is there a wartime pattern or not? Um, and a couple of people, like what they did was they sort of divided it, like rather than looking at this over time, people specifically took out the war year values. So I mentioned before, one person did looked at this in box plots. So you essentially had the war years, the non-war years, and kind of looked at um, what the difference was between those two groups. Um, and these are valid, but it's if you think about that, these questions kind of lead to more questions, because if you are really answering this question, you begin thinking like, how are you going? Are you just comparing this to your entire sample? Are you going to account for time at all? Some people like they did three divisions. They would do before the war, and then after the war. So there's a lot of different ways that you could look at something like this. Um, so yeah, overall, everyone did really well on this homework. And any other questions about this before we move on? Cool. So we'll move on to talking about homework three and about about talking about Shiny and beginning to build interactive web-based visualizations. So, um, so does anyone have any questions about the video that was posted, or do you want to just sort of dive into what the structure of these apps are? All right, um, so we'll just jump into what the structure of these Shiny apps are, and what sort of a bit about like structure of web apps in general, and we'll get into how to some strategies that'll work for homework three. So for homework three, we're looking at, got that right here. So we're looking at this mortality rate data coming from the CDC, and it should be fairly straightforward. The trick is just finding getting this to work within the Shiny framework. So basically, there are two questions, and for each of these two questions, you should essentially build a Shiny app. So what are Shiny apps? So Shiny apps are each one of these, like you could see how it's defined in defined in what the deliverables are. There's a UI.R and a server.R, and basically with assuming like the local, if you're pulling from local files, assuming all of that is mapped correctly, with a UI.R and a server.R, anyone should be able to view, build and like host the Shiny app that you build. So the two parts of a Shiny app, those correspond to common sort of the common framework of thinking about web apps. So looking at the what's called the client side and the server side. In this case, looking at the UI user interface or the server. And the way that you could so to kind of go into how this works with Shiny, each of these and uh, you should keep each of your apps in a separate folder. But assuming there's a UI and server.r, and there's not a second, like this is saved in another folder, but there's not a second UI or server there. RStudio is really good at picking out like those two files and realizing that you have an app. So when you do have an app here, you're able to just run it directly from RStudio and possibly get an error. Let me look at the. So I'm going to get out of these and I'm going to open up just the ggplot version. Been running into issues with Vega Lite. So first we'll go over Shiny in general, and then I'll get more into these other packages that I introduced. So we'll go back to here. All right, so first we'll go into the simple ggplot app. So, and we'll just run it so that we get an idea of what it looks like. I swear this was working. You guys saw the video. It's the same files. I don't know why this is not working. This is weird. My function's defined. Let's just try opening this up in the browser. No. Yeah, I've noticed this with the other packages, and this is just using ggplot though, so I don't know why this is giving me issues. So it looks like it's happening in here. And I bet I just need to bring in the library. Nope. Dangers of live coding. So there shouldn't be any issues with this, but for some reason, settable. Let me try opening up this here. Server UI. The weird thing is they're all getting the same error. Which leads me to believe there's something. So let me make sure. Okay, I'm not sure what's happening here. I should be. I have that. Yeah, that's why I ended up using just reading this from the web, because I do always do that. But yeah, that's loading properly. Oh, that's weird. All right, that's very weird. I'm not. I'll have to do some more digging into what happened there, but at least we're running now. So, in terms of the different sides of an app like this, client side, that's basically just anything that's showing up here. So, in R, it's very it's very clear that it's just looking at the layout. So you're defining like what your controls are, what your graph window is, and any other HTML output that that you're displaying. And you basically like Shiny has tons of built-in built-in elements for dealing with this. So you have things like select input. That's just a simple drop-down menu like this. You have and then you have things like plot output, verbatim text output. So that's just simply when you run summary, like it'll sort of run what comes out of the console, and and along with others. So there's a lot of a lot of options, and you kind of have to define like what your what type of output you have or what type of input you have in the layout. Um, so that's what's happening with UI.R. And you could see it's kind of this nested framework. So you have different panels, and then within those panels, you have your various elements. So um, basically, the elements that we have here, just looking at the layout, can anyone let me know how many elements are in this page? How many UI elements? Almost. Nope. Wrong direction. 5 was closest. Yep, that's it. 6. So so basically, what you have this you have the title. That's an element. You have the plot area. That's an element. This output here is an element, and then each of these drop downs is an element. And you could kind of see each of those defined here. Like you have your header, you have your inputs, and you have your two outputs. So, and basically, the way to think of these apps, and I think I mentioned this um, in the video, but there's a really like this is there are great resources on RStudio, like great documentation in terms of um, teaching yourself Shiny, and it really gives you an idea of the sorts of stuff that that you need to be thinking of. Um, and the way to really think of this is you have, this is your front end and it's communicating with an R session. So, like for this class, like we're not really getting into how these would be implemented, but if you're implementing these in, a professional setting, um, you would probably have an R server running somewhere. Like Shiny sells like their own servers that are, like you're able to have a Shiny server running and serve web apps to whichever user community you're serving those apps to. But basically, the way to think of it is you have this here, which is an interface to an R session that's running in the background. So you kind of have like, the client side, front end, and then you have the server side. And whenever you're making a selection here, so in this case, it's pretty straightforward. We're just looking at, um, making choices in our drop downs here. Whenever we make a choice that changes the output, we're essentially retrieving information from the server side. So on the server side, like that's where the data is being brought in, where data is getting sliced depending on what the input is. And when we make a selection here, that data is getting there's sort of a communication going to the server side. It's telling it's telling the server the user just chose Miami. These are the three inputs that we have defined. Let's return a graph based on those inputs. So, essentially you choose Miami, it'll give you, in this case, the housing prices for Miami. Um, so does that kind of like just broad architecture make sense? Cool. So that's the broad architecture of Shiny, and then I sort of used this example as a I sort of used this like the sort of this ggplot example as a way to get an idea of what sorts of questions you need to be asking yourself in this when you're building apps like this. So in this simple example, we have we have the data coming in, and so like we have our UI over here, and the way that you could look at this is something is changed. Something is changed over here. Um, the data comes in, and actually, this is not what I wanted open. I wanted the simple version open. So in the simple version, what we're doing is we're bringing the data in kind of all in one shot, and then we're saying, okay, we have our full data set. We're going to separately calculate that plot one and calculate that those output stats. So let's run this app. So first, just in terms of what's happening here, I have, and we have our data here, so I'll just sort of take a look at, let's stop the app for now. So just to take a look at the data that we have here, it's looking at this housing price index data, it's over time, and we have these three categories of housing prices. So whether it's seasonally adjusted or not seasonally adjusted, which metro it's in, and which housing tier we're looking at, whether it's high, middle, or low. And the way that we're looking at this is we're, on this graph, we're separating the traces by the tier, and we're using these drop-down menus to pick whether we're looking at seasonally adjusted or not seasonally adjusted, or the so in this case, we're sort of defining what the plot is, but then separately, we're looking at this over here, and that's being updated by this housing tier drop down here. So if I choose middle, you could see that this is, or if I choose low, that you're going to get a more apparent change. But when I choose a different housing tier here, you could see that this output is changing, but nothing's changing here because we're already looking at the three tiers. And in the video, I went through like kind of looking at um, a broader architecture of what's happening here. But over here, when you're bringing in all of the data and you're separately calculating that plot and that stats output, you end up you can end up with problems because if you're thinking about the logic of this app, you're considering this to be like a subset of this. So these two you're considering linked. Like we're looking at low housing tier in the summary, and that's the same data. This is giving us the summary of this data here, this green trace. But there's nothing explicitly linking them within the simple app logic. Does that make sense in terms of how, like with this simple app, we're not going to run into issues, but how if you're building more complex apps, these are the sorts of interactions that you want to think about. Okay. There's when we're going in here, I think it's app architecture. So this is just Shiny, the Shiny tutorial. And I think it's app architecture where, let me, so here, this is sort of where I got this example. So this is another good video that you could check out. And I posted the link to the tutorial. But basically, what's happening is you have your input and your output. It's sort of looking at like the output is defined in two separate ways. So they're not necessarily linked. Whereas if we looked at something like this, and this was in the video, like I was sort of getting into like this reactive function where this by necessity links the data. So what you're doing is you're saying, so essentially in our app, what we're saying is first, I want to subset the data by seasonality and metro area. And I want to use that for both this and for both the graph and the stats output. And then with that data, for the stats output, I'm going to perform another filter. I'm going to filter it by housing tier. And the difference there is you're, sort of performing, I sort of like the visual here because you could sort of almost look at it as a two-step process where you're performing your shared calculations and then you're sure that you're looking at like the same data when you're looking at your two outputs. But I would recommend checking out this video. Like the tutorials, they are kind of long. But yeah, this is around like, it looks like around the 45-minute mark. and that's this right here. So it's app architecture, and it's the sort of looking around like 45 minutes. But really, like out of the material out there, I thought that sort of gives you the clearest idea of like when you are dealing with interactions like this, these are the sorts of things that you should think of. I won't, for homework three, like it's not required to use these methods. It's just something to keep in mind. So if you guys make an app with, you know, like if it works, but perhaps it wouldn't be the best design if you're building things out, for if you wanted something more modular, if you wanted to kind of build a larger app and you wanted to make sure that you don't run into any errors that may only show themselves in an edge case. Um, that's not like this is sort of more meant to be introductory. Um, so it's just something to keep in mind there. And we're running out of time, but in the last 15 minutes that we have here, um, and I won't go through all of the syntax because there is the video that I posted that that should go through them. So we'll sort of use this as a quick Q&A session. Um, so has anyone like downloaded any of these libraries? And does anyone have any questions on how they're on how to use them or how like why they're useful for something like Shiny? So so the key takeaway of these has been that mhm, mhm. Yep, there's like when you're using these libraries, they do have um, a lot of times their defaults look prettier than ggplot. Although with uh, with ggplot, I always just go with theme tufty get a to get a nice looking theme there. But but yeah, there's a lot like there's a lot of there's good defaults and really like what the um, what the main kind of advantage of them in regards to Shiny is Shiny is a web development framework. These packages are essentially like they're repackaged versions of JavaScript libraries. So Google Viz is its own sort of charting API. Plotly and Vega, those are specific JavaScript libraries that um, that you could sort of use in JavaScript, but have been ported over to R. And it's similarly to how Shiny is a web application framework that's been ported over to R. So it's really like just keeping in line with like being able to make these sorts of web development tools accessible to the data scientist. And actually, the if anyone checked out this week's discussion, it's kind of going over this theme where the I ended up posting a talk from Plotly's chief product officer, and he's it's mostly about a new tool that we're working on, but but I thought the first like couple of minutes or so, the first like 7 minutes or so were useful for looking at how a lot of these tools, these web development tools, are being ported over to data science environments, and that's sort of the way that I think it's useful to look at these sorts of libraries. Um, but as I mentioned in the video, these libraries, they're not required for homework three. So if you are more comfortable sticking with ggplot, that's totally fine, and you could build your Shiny apps using ggplot. these are just some other alternatives that could make sort of utilize the more interactivity, like specifically with Plotly, where there is built-in interactivity. So you get in sort of the same syntax that you're building these Shiny apps, you're able to get like a fully interactive visualization. So, so Keith asked if we're going to be using shinyapps.io. You guys, so if you want, feel free to upload your apps to Shiny Apps, and if you have it running there, you could submit a link. Um, Still include the code so I could take a look at it. But feel free to like submit your apps there. In terms of the assignments that we have coming up, after this, we're going to be moving to Python, and so the Python assignment, it's going to be sort of um, static visualizations in a notebook. So that's not going to be using the Shiny Apps framework. And then and then after that, we're going to be moving into JavaScript. So feel free to use it for this assignment. And if you do choose to do your final in Shiny, feel free to use host it on Shiny Apps. That's definitely an option there. But we will be moving towards um, other frameworks going forward. All right. Does anyone have any questions? Any other questions before we dismiss? Has everyone started playing around with Shiny and got sort of simple Hello World apps up and running? Or has anyone not been able to get anything off the ground yet? Cool. Cool. That's great to hear. All right. So that should be it for the second question of so is this Andrew asked for the second question of this homework, are we looking for movement? Is this for homework 3 or homework 2? Oh, it's yeah, you don't have to have movement. Um, yeah, that would be above and beyond what we need here. So in terms of that second question, um, yeah, yeah, you don't need to do actual movement. If you want to take a shot at it, feel free to, but you don't need to. All right. Any other questions? All right. So good luck on homework 3, um, and let me know if anyone has any questions going forward this week. And I'll talk to you guys next meetup. Oh, one more thing. I'm sorry. I ended up posting. Did everyone see the post of the final project. I posted this link here. Cool. So I was talking. So the proposal that's going to be due on the 26th, I believe. So it's the same. So not this homework, but homework 4. It's going to be due on the same Sunday that that's due, and I'll go through your proposals. If there's any clarification needed, I'll talk to you guys individually. But essentially, it's very open ended, and it's just sort of meant to be. So right now, like just sort of think about like what sorts of data you want to look at, and maybe do some planning for what you would like to do with it. One thing I mentioned in the proposal is yeah. So the type of deliverable this is going to depend heavily on the sort of strategy you use, and that means like which sort of technology you use, like whether you're using JavaScript, D3, Plotly.js, whether you're using Shiny, um, etc. Whether it's static or interactive. I'm sorry. First, with the technology type, like obviously, that would like if you're using Shiny, it would be a UI.R and server.R. If you're using JavaScript, you would have to get something that I would be able to, essentially like host myself and run on a local host. And we'll get into how to do all of that when we get up to JavaScript. Um, so obviously there's that side of things, and then there's also just like conceptually, if you're looking at static visualizations, your write up is more important. So if it's an interactive visualization and you sort of are um, you could think of it as like maybe you're building an explorer, like you have a data set and you want a user to be able to make kind of explore the data set through the visualization. Something like that, like the write up is mainly just meant to clarify anything that's not apparent in the um, in the exploratory sort of app. But with static visualizations, it's the write up is a bit more important to provide context to what you're submitting. But otherwise, it's very open ended, and and the examples that my predecessor posted should that Josh posted, I believe the link I provided here, like that should be a good place to start for inspiration. So, any questions on that? The link is right here. So, previous final projects. So this is Josh Larito. He used to teach this class, and these are what previous students have posted. So just take a look at this, and should should give you guys some context. So anything else? Any other questions? All right, so I'll let you guys go now, and um, I'll either email me or ask in the forums if you guys have any questions about as you're working on this homework. All right, good night, everyone.